Hello, AGP students. This is Rob Jensen. I'm coming to you today to talk to you about the SAT October 2018 test, section 4, calculator section. And I'll be walking you through the solutions today for this exam. So, looking at what we have here, number one, we kind of see that we have a word problem here, the things. And so within that, then we see a linear equation that we're having to develop. This should give us a really good indication just by looking at the answer choices. So here it looks like we're most interested in understanding the constant and the slope for which this problem is. So here we're reading it. It says a helicopter hovering initially. So there's that word initially. So that means that's going to be hovering 40 feet above the ground. So that there looks like is going to be our B of sorts. So if we see 40 plus 40, 40t, so okay, that can't be it. So eliminating D there. It begins to gain altitude. So it's gaining altitude at a rate of 21 feet per second. Which of the following functions represents a helicopter's altitude above the ground, t seconds after the helicopter begins to gain altitude. So can't be that because there's not a slope there. This is a positive slope, negative slope. We know we're gaining, which means our slope is increasing. C is wrong, B is right. Okay, let's look at number 2 here, in which we have a graphing interpretation one. Remember, these graphing interpretation ones kind of look a little funny. Definitely does not look like a normal coordinate XY plane graphed of any sorts, and so we're trying to see what's being represented here in a word problem. Text messaging plan charges a flat fee of $5 per month for up to 100 text messages. So flat fee, $100 per month for 100 text messages and things. It's kind of funny. Back in the day, you used to charge for text messaging, where nowadays it's unlimited text. So here we see 500, 5 to 100. This one, see, it instantly goes up after that, so it cannot be this. And this one instantly goes down. Plus 25 cents for each additional text sent that month, which is the following. So we see that it's increasing of sorts, where this is decreasing, it's increasing. So we see A is the answer choice, and B is wrong there. Okay, so we have another, looks like graphing interpretation problem. Again, we're kind of being presented with these sort of weird graphs, lines of sorts. And so we're looking at one that sort of represents here. So Jake buys a bag of popcorn at a movie theater. He eats half the popcorn during the 15 minutes of previews. 15 minutes of previews. So the amount of popcorn in the bag, let's see, there's half. Looks like there's about half. And then here, D, it sees where it's going up. So we see that he's eating some of this, so there's less popcorn in the bag, where this is showing more, so D is not an answer choice there. After excuse me. After eating half of the popcorn, he stops eating for the next 30 minutes. So that means there's some sort of like plateau or pause of things. So there's 15, and so that should be to 45. So there's the next 30 minutes should be from right there to right there. That doesn't appear to be all that correct. Right there, right there. So that appears to be okay. So we know that A is out. And then right here, looks like there's another pause. So that looks like that is okay there. Then he gradually eats the popcorn until he accidentally spills all of the remaining popcorn. So spills remaining popcorn, well then, we see that this is gradually kind of going down the source, and then boom, none left. Here, it's refilling up, so it cannot be C, and it has to be B here. Things. Okay, look at number 4. Looking at number 4 here, it says basically we have a linear equation, and then we have this curveball. What is the value of 3x? So make sure you're solving for 3x here. So let's write this out. 20 minus x equals 15. Well, I want to move the x over because I want to get rid of my negative. Move this piece over the things. And so within that, I see that I'm going to have to do minus 15 here and do plus x. So we're going to have 20 minus 15 equals x, or 5 equals x. But that's not what we're looking for. So 3x that equals 3 times 5, which then equals 15. And so we can see the answer choice on this one is C. Okay. Number 5 is just a typical function problem that we have that's being presented to us. And so it says, what is the value of function of -1, which we have to take that and plug that into right there. And so we see the function of -1 is going to equal -1 plus 3 over 2. And then we're given 2 over 2, which is going to be, the answer choice is going to be 1, which is C on this problem here. All right, number 6 here says, which of the following is equivalent to 2x squared minus 3x, right? 2x times x squared minus 3. So here we're having a distributing here. We're distributing of sorts, and so we got to distribute into this and then into this. Okay. So now at first we see we're going to end up with 2x cubed, and so that eliminates that answer choice and that answer choice. And then we're going to end up with 2x times -3x is going to give me minus 6x squared. So that ends up giving me D as the answer choice. Okay, so number 7, we see a retail company has 50 large stores located in different areas throughout the state. A researcher for the company believes that employee job satisfaction varies greatly from store to store. Which of the following sampling methods is most appropriate to estimate the proportion of all employees of the company who are satisfied with their job? So key thing is all employees. So what we have, remember this question is a randomization. All right, this is a randomization question. And for that reason, we want to be able to examine what we have and try to have a sampling from, a random sampling from as many people as we possibly can from each store. So here, selecting one of the 50 stores at random and then surveying each employee at the store. So no, it can't be, because then you're only looking at one store, and you're not getting a sense of the level of satisfaction from everything. So you can't extrapolate from one store and try to apply to all 50 stores. B, selecting 10 employees from each store at random. So yes, that's really good. Then surveying each employee selected. So there's a good possibility that that one could be it. Could be it. Surveying the 25 highest paid employees of the 25. So no, that's definitely not it. The thing is, because again, that's not a random sampling of sorts. Creating a website in which employees can express their opinions and then using it first. So no, that's a volunteering of responses. Any volunteering of responses is not a legitimate poll of sorts and cannot be, which would then potentially what we call lead to bias and stuff. So B is the answer choice on this one. Okay, let's look at number 8 here. What we have is this graph, number of weeks, total amount of deposited dollars. We got 2 folks here, so let's see what's going on here. It says the 2 graphs above show the total amounts of data that Ian and Jeremy each have deposited into their savings account for the first 7 weeks after their opening accounts. After they made their initial deposits, how much more did Ian deposit each week than Jeremy, of sorts? So what we're trying to do is, this really is kind of like looks like a slope problem, because it's asking how much more after they made their initial deposits. So this is really a slope question. So we just have to pick 2 different points. So we can see that Ian here, let's just take Ian. So it looks like he has, Ian has 0 and 100. So you could say, remember we want to understand like the change in y over the change in x for each one of them. So Ian we have 0, 100 right there, right? And so that's going to be 0, 100. And let's pick another point that we have. And so that's going to be 3 and 400. So we can see that's going to be 403. So what we end up getting is, it looks like we get 300 over 3, or which is equivalent to 100 per week and such. So, okay, so that's Ian. So let's look at Jeremy now. Let's look at Jeremy. Put him in green here. And it looks like first point of Jeremy here, we have 0 and 300. 0 and 300. And you might be asking what I'm doing. Really what I'm doing here is this is just y2, y1 over x2 minus x1. So I'm just putting these values in first, since that's just what I'm looking at first. Let's get another even clean point. So we got a clean point here. And it looks like 2 and 400. So I'm going to put, okay, 402 here. So now I'm going to get 100 over 2, which then that's going to give me a value of 50 per week. And so Ian is collecting money at 100 per week. And you can actually see he's on a much steeper slope. It's climbing faster. Jeremy is on 50 per week. And it says how much more did Ian deposit each week than Jeremy? So Ian's depositing $50 more per week. Okay, let's look at number 9 here. And number 9, we see the function h is defined above. What is the value of h of 5 minus h of 3? Thing. So here we can just kind of rewrite these expressions. We say so h to 5 is going to be 2 to the 5th. So if you think about that, that's 2 times 2 times 2. So 2 times 2 equals 4 times 2 equals 8 times 2 equals 16 times 2. So that's 1, 2, 3, 4, 5. So that's going to give me a value of 32. So 2 to the 5th is going to give me a value of 32. And then let's do it in a different color here. Let's do h of 3. So 2 to the 3rd is going to be 8. And stop. And so we're just putting, because we got to put that value, make that a little bit more. And so now h of 5 minus h of 3 is going to be, what we have is going to be 32 minus 8. It's going to be a value of 24. And so our answer choice is going to be C. All right. So let's look at problem number 10 here. We kind of see that what we had is another sort of randomization question. All right. And for which this one is asking us, researchers surveyed a random sample of students from a large university about how often they see movies. Using the sample data, the researcher estimated that 23% of the students in the population saw a movie at least once per month. So you see 23% of the students in the population saw a movie. The margin of error in this estimate is 4%. So we see the MOE here is 4%. So really, that could suggest that it could go anywhere from 19% to 27% of things. Which the following is most appropriate conclusion about all students at the university, based on the estimate and margin of error. So here, A is suggesting it is unlikely that less than 23% of the students see a movie at least once per month. So no, that's not really true. I mean, it could very well be likely because given the margin of error, so that's wrong. At least 23%, but no more than 25%. So again, that's wrong again. The things because our range is 19 to 27. The researcher is between 19 and 27. The researcher is between 19 and 27% sure that most students see a movie at least once per month. So the language there seems a little bit awkward there when they're saying 93 or sure. And then D, it is plausible that percentage of students who see a movie at least once per month is between 19 and 27. So the fact that it says it's plausible means it's possible that it could happen. and things. And so this is more of the conservative choice, and so C is wrong because it says the research is between 19 20% sure. So that's a little bit too of an absolute, not quite like an all or none thing, but this one provides a more wiggle room for the answer response. Okay, number 11 here. We see we're talking about mean and standard deviation. So first we kind of want to figure out what the mean is to two, because it says the table above shows two list numbers. What's the following is a true statement. So we're looking at a true statement about these. Well, one, we see this is 1, 2, 3, 4, 5, 6. So we see these are in sequential order. So really, if we was to sum all these up and divide by 6, we're going to get a value for list A for the mean, which will be 3.5. And so if we do that for B, same thing, we got, 2, 5, 8, 8 plus 4, 12, 16, 16, and 21. So we end up getting 21. And so if you do 21 divided by 6, all right, and we can use your calculators since we're in section 4 if you're not uncertain. So 21 divided by 6 is going to give me 3.5. So you see that the means of these are the same, okay? So the means are the same, so that's good. The means are the same, good. The means are different, the means are different. So again, another divide and conquer strategy. So the standard deviations are different, the standard deviations are the same. Well, here we see that the values are increasing by 1, and so the spread here on them is more consistently than what is happening on this one, where you see it's here and split between the middle. You're close by just off of 1, and then you're off by another 1, and then same thing here. You have the same sort of behavior on this side as you do on this side. But so what this is suggesting is that probably B, the standard deviation, since the values seem to be a little bit more centered around the mean of 3.5, and so you can see it a little bit more closer through this area of things. This is going to have a lower standard deviation, while this one seems to keep continually spreading out, so that's going to have a higher one. So we see that A is the same. The answer choice, and B, the standard deviations are not going to be the same. All right, let's look at number 12 here. We see we have a percentage problem, and we just need to decide if it's decimals or change of. The book was on sale for 40% off its original price. So again, we see that's going to be a decimals. Okay. If the sale price of the book was $18, what was the original price of the book? Well, what we can do is, this is a good trial and error question of things. Okay. And so for that reason, we can just choose one of these and see what so happens to work. So if we choose, say, C here, so if I take $30, and it's 40% off its original price, so that really means that I'm having to pay 60% of the value. So that's going to be 0.6 of things. So again, using my calculator, I can see 30 times 0.6. That is going to give me 18. That matches what I have in here. So therefore, C is the proper answer choice of things. Okay, so what we have here on next one here is number 13. You see we have a graphing interpretation question, looking at what's going on up here. So it says, which of the following colonies showed a decrease in size every 2 weeks with initial treatment with pesticide? So let's take a look at here. We got a Roman numeral, so we want to tick them off, one by one. So colony A, you can see we're right here, and it drops here, drops here, drops here, and drops here. So colony A is indeed correct and good. So we can eliminate B. Answer choice B there. So let's look at colony B now. So colony B is represented by the speckled bar chart. So it's here, and it kind of slightly drops here, then there's a big drop, and then you see this one is on the line of 40, and then this one is below the line of 40. So you kind of have to expect this one a little bit closer, and then down here. So obviously, okay, B is good too. So for that reason, A is out, and now we're trying to decide between is 3 good, or is colony C good here? And colony C we see here, and then it jumps up. So of course, yeah, then there's a drop, but that's after a couple weeks of treatment of things. So that C is not good. So the answer choice here is C, and D is incorrect. Okay, let's look at number 14 now. It says, which of the following which is close to the ratio of the total number of insects in all 3 colonies in week 8. So we're looking at week 8. So if we go over here and look, and we don't really need to be exact or precise. We can say, okay, well, that's 20. So we'll just say that's 20. That is 10. And that looks like 50. So if you add up all those, we can say, okay, well, that looks to be about 20, 10, 30, 50. So it looks to be about 80 for week 3. And then I'll use another color for week and to the total number of insects, at the time of initial treatment. And so the initial treatment would have been here, and we see this is 80 here. And then this is just above 60, and this is below 60, so I'm just going to call those each 60. Doesn't really matter. So 60 plus 60 is 120, 120 plus 80 is going to give me 200. So let's work on reducing those out. I'm going to cut those in half. So that's going to be 40 to 100. Cut that in half again. That's going to be 20 to 50. And then drop the zeros. So I'm going to get 2 to 5, which I can see the answer choice here would be A. All right, let's look at number 15. It says a right circular cone has a volume of 24 pi cubic inches. If the height of the cone is 2 inches, what is the radius in inches of the base of the cone? So remember the cone, we're talking about a right circular cone. The formula for the volume of it is going to be volume equals 1/3 pi r squared. And if you're somewhat, remember, you can always flip back to the front. So you can always flip back to the front, and you see that is being circled right, or being right there. Oh, times the height. So forgetting the height. Good thing I went back and checked there. I would have picked that up because I do have a height in here. So, and so for that reason, we can see the volume is 20. So we can say, okay, V equals 24 pi. The height equals 2 inches. And then we're trying to solve for the radius. So we just plug in those values. Use a different color here to kind of help me out a little bit. So I'm going to say, okay, 24 pi equals 1/3 pi times r squared times 2. All right. So what I can try to do on this one is we're trying to figure out the radius of this. To get rid of that, well, let's see here. What would be a good step that I could do? One of the things I probably could do first is, let me go ahead and erase this piece. Make this a little bit easier. Let's go ahead and divide by pi. Let me see if I can do well. All right, let's simplify this further. So 1/3, so that's going to be 2/3 pi r squared. It's 24 pi. So let's multiply this by 3/2 of things. So that's going to eliminate that, and so multiply that by 3/2. So that's then going to give me 3 times 24. Let's see. Well, let's divide that in half. So that's end up going to be 3 times 24. Get my calculator. It's going to be 72. It's going to be 72 pi divided, so let's end up 72 pi divided by 2 is going to give me 36 pi equals pi r squared. Well, now I can divide by pi. So now I'm left with 36 equals r squared, or take the square roots of that. And what I so happen to get on this one should be 6, which should be B and stuff. And so looking at it, yes. And so I get 6 equals R of things. So, good deal. Alrighty. Okay. Let's look at number 16. We see that we're dealing with another percentage problem. All right, and for that reason, we see this one as a decimals, because remember our decimals are increasing and decreasing off 100%. And this problem is probably a little bit more challenging than most, and I'm a little surprised that it's kind of stuck here at number 16. You know, I probably at a level 1 through 5, I would maybe categorize it more closer to a 4 than what a 3 is. And this is definitely they're rating as a medium problem. But okay, let's take a look at it, and you kind of have to parse between the words a little bit more. So it says in 2015, the population of city X and city Y were equal. So from 2010 to 2015, the population of city X increased by 20%, and the population of city Y decreased by 10%. If the population of city X was 120,000 in 2010, what was the population of city Y in 2010? All right, so you kind of have to look at this one a little bit closer and tackle it in pieces here. We know that in 2010, right, X has what is saying is to be 120,000, right? And then in 2005 to 2015, it increased by 20%. So we would then multiply this by 1.2, and that's going to give us a value of 144,000. Now, keep in mind, you have to bear in mind that the populations for Y and X in 2015 were identical. Okay? And this way, there was a 10% reduction. So we actually got to figure out, so there's more, so citywide lost population. So we know this value has to be bigger than, 144, right? Because Y lost populations of things. So it cannot be B or A for sure. And so it's just by how much. And so what we can do, and C is probably the next best answer choice we could look at. So if we take C, all right, and look at it, and so if we say there is 160,000 folks that was in 2010, so we're saying hypothetically, and there was a 10% decrease that should take us to the 144,000, right? So we then multiply that by 0.9. And if you do that math on our calculators, and we get 160,000 times 0.9 gives me 144,000, which then matches what I have here. Therefore, C is correct and D is wrong. Okay. So again, that one's a little tricky, and you kind of have to maybe draw it out like I did, just to sort of help to keep things straight. Okay. So here we see we have this equation, right, that's being given to us. And we notice this language in terms of, right? And so this is just a rewriting an algebraic expression. and we're writing it from V to where it's now in R. So all of these are going to be R equals, R equals, R equals, R equals. And we're trying to isolate that R. So let's rewrite the expression. So V equals 4/3 pi R cubed. The first thing we want to do is multiply by the reciprocal fraction, which is going to be 3/4. So we want to multiply by 3/4 here. And so we get 3V/4 equals pi R cubed. So we got 3V/4. So this is 3. So this cannot be it because the 3 and the 4 swap. 3/4. 4/3. Nope. 3/4. We want to then divide by pi. And so over here we're going to divide by pi. Things. So what then that's going to do is now put the pi in the bottom. So now we have 3V/4 pi equals R cubed. And then we got to take the cubed root here, and we got to take the cubed root over here. So therefore, that eliminates B and gives us D as the answer choice of things. So if you're a little bit fuzzy, you should know there's a cubed root over here. So helping to eliminate that and whittle it down to answer choice B. All right, let's look at number 18 now, what we have here. And so 18, we see we have this table in survey results. It's the table above, result how often they would watch video advertising in order to access streaming content. Based on table, which of the following is closest to the probability that a tablet user answered always, given that the tablet user did not answer never? Okay, so let's look at this and read it one more time. Based on the table, which of the following is closest to the probability that a tablet user answered always? Okay, always. Given that the tablet user did not answer never. Okay, so the sum between these pieces, okay, and because they did not, given the tablet user did not answer never, so that's eliminating that from that piece. So, then you're looking at the sum of those would be 69.7, okay? And then of those, 30.9% answered those. So if we tried to do that, that would be 30.9, because that would be the always, that a tablet user answered always over, given tablet user did not never, 69.7. And so if you do the math on that one again, so 30.9 divided by 69.7, and you're left with 0.443. So you're left with 0.443. And looking at that one, you can see the closest answer choice is C at 0.45. And so it doesn't have to be exact because it says closest to the probability. Okay, so what we have here is, looks like we have a quadratic, and specifically we're talking about vertex form. All right, so you want to keep in mind that this is going to be y equals a times x minus h squared plus k. And the question is saying a is a constant. It says the graph in the equation in the xy plane is a parabola. Which of the following is true about the parabola? Well, looking at our answer choices, we see this -3 and a, so it keeps making reference to that. So if it's saying that it's -3, then we really know the vertex has to be at +3, because if that's -3, then the vertex has to be +3. So that eliminates that one and that one. And the other thing is we see that it says that the other parts is at A, right? So we see that the vertex is going to be at 3A, but that's not what it's asking us as well. It says its minimum occurs at 3A or its maximum occurs at 3. Now remember, this is a negative parabola, so that means what we have going on is on our XY coordinate plane, we have something that's doing this. It means it's shooting upside down. And for that reason, we see whatever that is, we'll say that point, that's going to be 3A, and so that has to be the maximum because it cannot be any higher. So that has to be the maximum value, and therefore B is wrong. D is the correct answer choice for this one. All right, guys, let's look at number 20 here. We see we got a mean, median, range, standard deviation type problem. So we're dealing with some central tendency data. The question reads, the maximum value of a data set consisting of 25 positive integers is 84. So we know that they're positive and they have to be, one data set to be somewhere between 1 and 84. Okay. And a new data set is consisting of 26 positive integers. So we're adding a value onto here. So we're going, and is now created by including 96 in the original data set. So now the new data set, so this is the old, this is the new, it's going to 1 to 96. Or hypothetically, somewhere values are in between that range. Which of the following measures must be 12 greater for the new data set than the original data set? Well, just because we're increasing by 12 and we have 25 new and 25 or 26 values now, so you have increase of 12. Let's do this. So you have an increase of 12, but you still got 26 values, so you're not going to increase this by, there's no way you're going to increase this by 12. Okay, because whatever value that is, it's not going to change the mean by that much, so it can't be that. And the median, again, is probably the least affected by any sort of change because the value is being pushed off from one to another of things, and so it doesn't really matter what was in the middle. It might move it over just a little bit, but still, the median is going to probably largely remain the same because if you had a data set of 1 to 25, the median there would have been 13. Well, now you've got data set 1 through 26. The median is going to be 13 and 14 averaged together of things. So again, very little change there. The range, however, you're increasing it by 12. We know at the most, or that the most on the first one is 84, then the second one's 96. So we see there is a differential. It doesn't matter what number you're coming from, whether that's 1 or say 30, right? Hypothetically 30, you're still increasing it by 12. And the same thing, the standard deviation is having some variation of the mean and stuff, and so you won't have that much change. So C is the answer choice here. All right. Okay, so let's look at problem 21. It says Clayton will mix X millimeters of a 10% by mass saline. Okay, so X millimeters of a 10% mass by saline. So we see that represented in this first piece here. With Y milliliters of a 20% mass by, so we see that being there. In order to create an 18% by mass saline solution. The equation above represents the situation. If Clayton uses 100 milliliters of the 20% by mass saline solution, how many millimeters of the 10% mass by saline solution must he use and stuff? And so, so we have this formula, and this is making reference here to the Y value. Okay, and so the 100 millimeters making reference to the y here and to the y there. Things. And so we can insert those and see what we have to get. So we're going to get 0.1x plus 0.2 times 100 equals, excuse me, 0.18 times x plus 100. All right. And so now we're going to end up getting sort of reducing our factors here. 0.2 into 100, so that should give me, that's a fifth of that, so that should give me a value of 20 equals 0.18x. And then 0.18 of 100 is going to be 18, so it's going to be plus 18. All right, and I do not necessarily want to have a negative, so I want to be able to move this piece over here and then move this piece over here. So now my equation is going to be 20 minus 18, okay, 20 minus 18 equals 0.18x minus 0.1x. So I'm going to be left with 2 equals, which is going to be 0.08x. Now we do have the use of our calculator here. And so for that reason, we really don't need to multiply through with the decimals. And so we can see that our value for this is going to be 2 divided by 0.08, and will give me 25 as the answer choice. And so for this one, you can see that the answer choice for 21 will be B. So 25 equals X. So again, this is just a word problem. This is a linear equation, word problem. Matching up the proper units to the proper variables, and then being able to solve. Okay, let's look at number 22. And number 22, we see that the first, well, first looking at the answer choices, we see we have linear, exponential, exponential. So we need to determine whether is this, which is describing linear or exponential. First year, Eleanor organized a fundraising event. She invited 30 people. For each of the next 5 years, she invited double the number of people she invited the previous year. Now, that language there is synonymous with an exponential function, so we can confidently eliminate A and B there. If f of n is the number of people invited to the fundraiser in years after Eleanor began organizing the event, what's the following statement best describes the function? Well, again, we know it's not linear, and if she's doubling the number, it means she's increasing, so that means makes D the correct answer choice. Okay, number 23 here is that we see that we have this this table. It's not really, it's kind of like a function table, but it's a table. We have the values of x's and y's, and this is probably a pretty unique presentation. You don't see many of these being done with the use of constants, and so this might, first glance be a little bit odd in its presentation, but really it's a lot simpler than what it looks. It's asking if there's a linear relationship between x and y, which the following equation represents the relationship. Well, here, just keep in mind, just taking what values are given to you and see what equals what. Well, it says here x equals a, and so if we replace that on this first one, just sort of seeing that, so we get a, because that's what x equals, right? Plus, and it says y is equivalent to 0, so then that would be 2 times 0 there, equals a. Well, that is indeed true, because 2 times 0 is going to be, that is gone, and so now you get a equals a, and that is indeed true. And so if you try to do all these others just as well, you see a plus 2 times 0 equals 5a. So again, those do not agree with each other. And and so for that reason, 2x, that's going to be 2a minus, which y is 0, right, equals negative 5a. So again, those do not agree with each other. And the same thing on the last one, same similar thing. It just says 7a on the bottom, and those, again, do not agree and stuff. The other thing is what you could always try to do is just make up a value and say like a equals 1, right? And so just put something in, and then you can then sort of make up and the rest of these values. And so that would be negative 2 for things. And see what works. And so you'll see that A answer choice works out just as well. So 2y equals A. X here, which in this course is A, which is 1, plus 2 times 0, which we said A is 1. And you see that checks out as well and helps me to answer that one. So you could always make up values for the constant and then replace those and see how they so happen to work in the actual equations below. Okay, so let's look at 24. We have a scatter plot, right, or line of best fit presented to us. And it's asking us basically which of the following could be the equation of the line of best fit. And so we see that, double check, there is no 0 there, so there's no intercept for which we can try to figure out. The best thing we could try to do is just pick 2 points and try to find the slope to this thing. And so we could just say, let's pick this point and let's pick this point to thing. So this one we can see is going to be 140. So we'll say the first point is going to be looks to be 140 and 70. And the second one we've chosen, so again, it doesn't really matter. We just want to choose something that looks to be pretty clean. 180 and 90. So this is x1, y1, x2, y2. And so we want to do the change in y over the change in x. One, we do know this is a positive slope, so it eliminates a and c automatically. And so 90 minus 70, so 90 minus 70 over 180 over 140. And we're going to see if we get 20 over 40, or essentially as 1/2. And so that confirms B is the answer choice and not D. Okay, so 25 here, we see that we have these systems of equations, and we're presented with decimals, right? So we see systems of equations, and we have decimals, right? Well, let's make this a little bit easier, and we see we're into the tenths here. So rather than having to use these decimals, multiply everything by 10. Same thing here, multiply everything by 10. And let's eliminate those decimals. So now we have essentially, which is going to be 24x minus 15y equals 3. And then on the bottom, we're going to have 16x plus 15y equals 13. And it's asking, what is the x coordinate? So if we're looking for the x coordinate, that means we want to eliminate the y's. We see where, sorry, that is, oops, I messed up right there. That is not going to be, that's supposed to be, sorry, 5y, 10 times 0.5. That's going to be 5y. Okay. Now, from here, it looks to be a little bit, daunting, but really it's not. We'll just multiply all this by 3, and let's carry everything over this direction to help us in solving for it. So let's write again. Top, we're going to have 24, because I can see I can eliminate the y's and get solve for my x's really easy here. So 24x minus 15y equals 3. 3 times 16, that's 32, that's 48x, so it's going to be 48x plus 15y, and that's going to be 39. Now I can add, and so 48, 24 is going to give me what, 52, 72, so 72x, and these are going to thus eliminate, equals 42. And so therefore I can divide by 72 here. Divide by 72. And so x is going to be, split that in half, that's going to be 21 over 36. Divisible by 7, divisible by 7. Nope, not divisible by 7. So let's see what my calculator says. 21 divided by 36 is going to be 0.58. Did I do something wrong on this one? Let's see, 24, 15, 3, 13, 5. Oh, no, that's right. That's so 16 times 3 is 48. Again, 2 divided by 72. What the heck am I doing? Sorry, guys. Looks like I've gotten a little lost on this one. I may have made a mistake somewhere. Getting a negative value. Oh, I see what I did there. I see what I did. Okay, good job. Go back and check. That's supposed to be a negative 13 there. I see what I did now. And so this is a really good try over again. Like I said, this stuff does happen, guys, and I realized my answer choice was not a part of the answer choices. And so for that reason, I made a cardinal mistake and rule that I messed up and stuff. So, one second. So let's try this again. So we're going to have 24x minus 15y equals 3, and that's going to be 42x minus or plus 15y, and that's going to be a negative 39. So that was my apologies. That's where I made a mistake of not distributing my negative and somehow forgot that piece right there. So now I have 72x is equivalent to what is going to be negative 36 divide by 72 divide by 72. So of course that is going to be x equals negative 0.5, which is going to be A. All right, let's look at number 26 here. We see that Keith modeled what we see is this is an exponential function problem just by glancing at the answer choices, right? We see this is exponential function, and so we're kind of seeing as what's going on. He says he estimated there would be 310 pollen grains per square meter the first year, so that's going to be the A there. So we can see the A here. Remember, our formula is going to be y equals A. X, which is percentage, times the B term. So we can see the A is going to be 310, which that's in all of these, so it doesn't really help. We're deposited with a 1% annual increase in the number of grains per square centimeter after, which is following functions beyond that. So these here are wrong. We can look at these terms, and that's wrong. And it's a 1% annual increase. Well, this is suggesting that's a 1% annual decrease. This is suggesting an increase. And so that is wrong. This is right. And D is the answer choice on 26. Okay, number 27 is we see that we have this linear equation, and it's actually these pattern ones. We sort of went through that. So it's an LE pattern type equation. we're given this 3x minus 2, and so we want to be able to look for that pattern that exists within here. And so we see that we have a 9x minus 6 and a 9x minus 6, which is both 3 times as much as this in that. And so what we can kind of do is we can sort of distribute this into this of things, or actually distribute the 3 and divide by 3. So we can rewrite this expression as 2 times 9x minus 6 divided by 3 minus 4 equals, and we can actually pull out a 3 out of here, so that's going to give us 3 times 3x minus 2 things. And so now this is going to give us 2 times 3x minus 2, which resembles what we're trying to get here, minus 4 equals 3 times 3x minus 2. All right, and so what we can then do is we can then divide by 2 times 3x minus 2. Divide this by 2 times 3x minus 2. So there's going to be 3 of these, and so what you're going to have is a remainder of 1 left over. And so for that reason, the negative 4 will drop, and then you'll be left with 1 over. And so you will then have negative 4 equals 3x minus 2. So that's the easiest way to get this response. What the other thing you can try to do, which again, this is not a very easy one, is just take these whole number values and plop them in, and so you could use a second approach, could be the trial and error approach, because we know one of these has to be in finding out what x is. Well, quite honestly, I'm sorry, that won't even work here because we have the 3x minus 2. You could try to go through this and solve this through the linear equation way of, trying to simplify and things like that, but we should hopefully notice that with these patterns that are in here and be looking for them in the later parts of the test of these types of questions, because they are more difficult in that in trying to solve for this. Okay, so let's look at number 28 here. It says the function f is defined above. If k is a positive integer, which the following could represent the graph of y equals f of x in the xy plane. So this is telling us that if k is a positive integer, so let's just make up let's just say it's 2 or something like that. And that means we should have intercepts at negative 3 and 2. And so we see that negative 3 here, that's going to be 1, 2, 3, so that checks out. However, the other thing we notice about this is that this is a positive quadratic. So automatically I should notice that A and B are gone as answer choices. And so here I'm looking at the other one. So we see that's going to be at negative 2, which that's wrong. And then that one's at positive 3. So D is the answer choice. It should be that simple. Noticing that we've got a positive quadratic, eliminated A and B, and then one of the intercepts is at negative 3. So being able to solve for that. All right, let's look at question 29. And what we should notice immediately off question 29 is we have this linear equation that's been given to us. And if we kind of skim through, it says, what is the meaning of 1.88? And so remember, these types of questions that we have, these are linear equations, but they are the modeling variety. And basically, remember, the modeling questions means we're just trying to understand one element of this equation. And remember, it's also going to be in the form of y equals mx plus b. So it's mimicking this. And so 1.88 we see is the slope. So we see the slope is equivalent to 1.88. And remember, the slope is always going to have some sort of increase or decrease a part of the expression or the answer choice. So within that, we can just go through the answer choices, and if you're having to guess per se, be able to sort of eliminate that. And so this one doesn't even have increase or decrease in it, so A is out automatically for that reason. We see B, C, and D. And remember, the slope is the same thing as the change in Y over the change in X. So if we break this down, it's going to say that the formula can be used to approximate the height h in inches of an adult male. Okay, so h is the y here. So we see that h is with the height in inches. Over L, which is based on the L, the inches of the femur. So we need to find something that mimics, and since this is a positive slope, an increase of height over length. And this one says the approximate increase in a man's femur length. Well, femur length, that's associated with the L here. So for each increase of 32.0 inches, and that's not even related because 32.01, that's the y-intercept. So that's definitely not it. So let's read C. It says the approximate increase in a man's femur's length in inches for each 1 inch increase in his height. Well, that's saying there that you have the length over the height of things, and so that doesn't necessarily seem appropriate. And so D says approximate increase in a man's height in inches for 1 inch increase in his femur length. And so you see that for each. Remember, each. That's remember, as we've always said, that means a fraction relationship. So man's height, there's the h, fraction, increase femur length. And so it's easy as that. And if you understand what this is suggesting and what we're looking for, you can read the answer choices and answer based off units. So D is the answer choice here. Okay, so let's look at number 30. It says in the quadrilateral ABCD above, AD is parallel to BC, and CD equals 1/2 of 1/8 of 1/2 of AB of things. So what we can kind of take from this is what is the measure of angle B? So we want to understand what this measure of an angle is, right? Well, one thing we can do is, since these are parallel and we see that's a right angle, we can also draw a line down from here to here. And that, I know that's not very straight, but we know now we have a triangle now. Now remember, we've always said if you see triangles on this, first things we need to look for triples. And if we don't see triples, we need to try to look for specials. Okay? And you have to sort of embed that into your memory when you're working with triangles for the SAT. That's just predominantly almost all the problems are going to be based off these two concepts. Well, it tells us that CD is 1/2 of AB. So that means that, well, to represent, we can say, okay, well, that's 1, right? And then this is 2, right? So that relationship is true because CD is 1/2 of AB. So that means that if AB is 2, then CD is going to be equivalent to 1. Well, what does that look like? All right. Well, if you remember and if you recall, okay, remember your triangles and such, and remember our specials of sorts. Remember you have x, you have 2x, and you have x to the square root of 3 of things and such. So what that is now suggesting here is that this angle, okay, this angle from across from here of things, get another one, get another color. So this angle from across from the 1 has to be 30 degrees, right? So if that's 30, then this has to be 60 degrees. And so if that's 60 degrees, we already know that that's right 90. So we know that angle B has to be equivalent to 150 degrees, or answer choice A. So there you go. You see how this one is sort of a little bit differently using right triangles. And it's been what we can call these types of shapes, we call these conjoining shapes. and sorts. But within it, we have to understand that when we created this triangle here, that we have to use probably one of either the triples or the specials here to help us understand that angle of things. Well, triples wouldn't really reveal the sort of angles to us, but specials does. And so knowing that, it has to be either 30, 45, 45 or 30, 60, 90 there. Answer choice is A. Okay, so let's move on to, whoops. The answer choice is A. All right, let's move on to number 31 here that we have. Okay, 31 is suggesting to us that Lynn has $8 to spend on apples and oranges. Apples cost 65 cents each and oranges cost 75 cents each. There is no tax on this purchase and she buys 5 apples. What is the maximum number of whole oranges that she can buy? Okay, so we see that she is going to buy 5 apples. There's no tax. She buys 5 apples, and apples cost 65 cents each. So we can say, okay, well, what she spent on apples is going to cost 5 times 0.65. All right. And using our calculator, we can kind of see what we happen to get for that. So 5 times 0.65 gives me a value of 325. So we can see that 325 is what she spent on apples, and we want to know how many oranges that she can buy at 75 cents each. So we then figure out the difference between that and what she spent. So the difference would be $8 minus 325, and so that's then going to give us 475. 475. And it says, what is the maximum number here? So we got to be cautious of that. So 475, and we got to then divide by 0.75. And we can see, what does that then give us? So 475 divided by 0.75 gives us 6.33. Of course, we cannot buy a third of an apple, so our answer has to be 6. Okay, number 32 is what we see is in the triangle below, if A equals 34, what is the value of B plus C? And so if we know this is equivalent to 34 degrees, then B plus C is really just going to be 180 minus 34. And so doing that math on there, you end up getting what is equivalent to 146. So, okay, number 33. It says if the mean of the 5 numbers is 1600, what is the value of x? And so if we know the mean of these, so this is a mean, specifically what we call an extrapolation problem. All right, and so what I can do is I can take, well, what is 1600 times 5? Well, it looks to be about 5,600 times 5 is, so that should be 8,000. Should be the answer there. 16 times 5 is, yeah, 8,000. And then from there, we can just subtract all these values. So we can subtract, so 700 plus 1,200 is going to give me, that's going to be 1,900. 1,900 plus 1,600, so that's going to be 25. That's going to be 3,500. And then 3,500 plus 2,000 is going to give me 5,500. So minus 5,500, I can see that my answer choice would then be what? 2,500 there. Okay, so then let's look at number 34 for what we have here. 34 says the relationship between x and y can be written as y equals mx. So this is what we call a direct relationship. So, so what that really means is basically is x gets bigger, so does y. Things can be written as y equals mx, where m is a constant. So if y equals 17, when x equals a. So if y equals 17, so if, when x equals a, what is the value of y when x equals 2a of things? All right. All right, so if we're saying that 17 equals, and m is a constant, right? Things, and when x equals a, right, and stuff, then what is the value of y when x equals 2a? So again, m is a constant value, and so now you have this is 2a. Well, that is just going to be double of whatever this is and stuff. So, you know, if we use whatever that is, it doesn't, you know, is again, m is a constant value. Then looking at this, we can see that it would be 34, because again, if we know that is equal to 17, then 2a, so that's 2 times the value of that, then that would then be 34. I guess one way that I could probably explain this a little bit better is we know that m times a equals 17 of things. So, and let me see about doing this. So to help you kind of see this a little bit more clearer. So now if we're doing, essentially, we're trying to figure out what y is if x equals 2a, then we know equals, m times 2a, but if we really move this around, really that is nothing more than 2 times ma, right? And we've already said that ma equals 17, so then we have 2 times 17. Again, that gives us 34. And so, again, what we call this is a direct variation problem. And so what we call this a direct variation. An indirect variation problem would basically mean there's a negative slope. They're inverses of each other. That would mean that you have y equals k over x. And so that means as x got bigger, y would then get smaller things. Okay, let's look at number 35 here and what we have for this one of things. So it says in the equation above, a and b are constants. If the equation has infinitely many solutions for x, what is the evaluation of b, value of b? Now remember, infinitely many solutions. Now, when we have these linear equations, our goal is always to eliminate x values. Okay, eliminate the x's. So what we could try to do and see what sort of pattern that we have here, it says what is the value of b? Well, if we distribute this into this, right, and if we do that, we see that we end up mimicking the other side. So we end up having ax plus ab equals 4x plus 10. So in doing so, we then know to eliminate these x's that a has to be 4, right? Because it infinitely many solutions. And so what we want to have is a value that is, they're equivalent to each other. Remember, when there's infinitely many solutions, we know that one constant value is equivalent to the other constant value and stuff. So to do that things, we now know that, okay, this is going to be 4x plus 4b equals 4x plus 10. And so from that point, we know that the x's are gone because we're eliminating those. And we're reducing down, so now we have 4b equals 10. Divide by 4. And you get b equals 2.5. Or 5 halves. Either one of them. Or 5 halves would be the correct answer choice. Okay, so let's look at number 36 here. And what we can see here on number 36 is you know, we see that a line that has equation y equals c. So y equals c. For some constant c intersects a parabola at exactly one point. If the parabola has the equation y equals negative x squared plus 5x, what is the value of c? And so what we can derive from this is that if we find what an x value happens to be, then we know what the y is, and then y is then in return equivalent to c of things. And it's the key thing is where some constant intersects a parabola exactly one point. Okay. Well, from this we can find what our intercepts are. All right. And there's a couple of ways to solve for this one. So we can find the intercepts here by pulling out what happens to be, say, negative x. And so we can say y equals negative x times x plus 5, right? And so if we then set those, we now know that our intercepts, because you'll have negative x equals 0, which then x equals 0, and then you have x plus 5 equals 0. Actually, I'm sorry, that should be a positive, or that, because I'm pulling out a negative there. Sorry, that should be a negative 5 there. So that will make that x minus 5. And so that means x then equals 5. So if we was to chart this, all right, if we was to chart this, so there's two different ways that you can do this. And say we now draw our parabola because we know it's going to be an upside down parabola. We know that the intersections of these things, okay, the intercepts has to be at 0, 0, and has to be at 5, 0. Things. Excuse me. And so for that reason, we now know that x in the center here, right, because the vertex has to be split in half, the things has to be at 2.5. So the x value has to be at 2.5, right? We know that. I know this isn't really drawn that well, but we know that this has to be. Well, what we can do is take this 2.5 and stick it back into this equation, which then gives us the y, because we know that this other line that's coming through, y equals c, is going to come right through here on the vertex of this one, because it says it touches once. Again, I know this is not drawn that well, but the point is that we're touching the max of the parabola, okay? And so for that reason, we know that. And so so that then we can say, okay, we could put that into your calculator. You could say y equals negative times 6.25 squared of things. Actually, hold on. Should be probably squaring that value plus 5 times 6.25. And if you end up putting that in your calculator, so if I have negative 6.25, I square that value, squared, plus, let's see, let me see, and then minus, what is going to be, or sorry, and so if we do that calculation there, oh, what am I doing here? My apologies, guys. I don't know why I have that in. I don't know why I have 6.25 in there. Sorry. I'm thinking here. Sorry, this should be 2 point. Sorry, I think I'm multiplying. So 2.5 squared, 5 times 2.5. So if you end up doing that in the calculation, you end up getting, you're going to get y equals 6.25 things. And so that there what gives you the answer to this one here. So you could do it like that, and where you find the intercept, the x-intercept, right? And that's predominantly the what we're trying to do is we find the x-intercepts, which we know are 0 and 5. And then once we know that, we split it into half to find the vertex here. And so we find the vertex by saying, or sorry, the x value of the vertex by saying splitting those in half, because it's equal distance from each other. We then pop the x back in here, and then for that reason, that's what we did here, down here, and then you get the value of y, which value of y isn't equal to c, and we see that the answer choice is this. Okay, so let's look at number 37. It says a peregrine falcon can reach speeds up to 200 miles per hour while diving to catch prey, making it the fastest animal on the planet when in a dive. What is a peregrine falcon's maximum speed while diving to catch prey in feet per second? Now, remember with these rates questions, we have to figure out what are we in and what are we trying to get to. And so we see that we're in miles per hour and we're trying to get to feet per second. So you see that there's two different rate conversions that we have to transfer. We have to go from miles to feet and hours to second. And so that's how we want to be able to set up our chain. So if we're in 200 miles per hour, and I see that 1 mile is equivalent to 5,280 feet, and I want to eliminate the miles, so then my conversion factor would be 5280 feet over 1 mile. So now I'm eliminating the miles, right? And doing the calculations here. So 200 times 5280 gives me 100, actually gives me 1,056,000. So that's what I end up getting there. So I get 1 million. Sorry, let's try this again. So I get 1, 0, 5, 6, 0, 0, 0. Yeah, there we go. So feet over an hour, right? But now we're in hours, and we now that we're in feet up top, so we satisfied this condition here, we satisfied that one. Now we need to get to seconds, right? And from hours, I then know that I need to convert that over, so I know that 1 hour is equivalent to 60 minutes, right? And so I can now divide by that. Looks like I'm going to really run short on room here. So divide by 60. And that's going to tell me that I'm now diving at, let's see, because now my hours are gone. So now I'm diving at a rate of 17,600 feet per minute. Okay, but I don't want to be in minutes. I want to be in seconds. Okay, and so then I can okay, I know that 1 minute is equivalent to 60 seconds. And so now I need to do another division there. So divide by 60. And it's asking round to the nearest whole number here. So then I end up getting what looks like to be, yeah, I'm going to get 293.3, but then it asks for the whole number, so 293 is my answer choice for this one. Okay, so that's how you do it. So you can see how I sort of mapped this up top and solving for this problem and going through and working through it. All right, number 38. If a peregrine falcon dove at its maximum speed for half a mile, so dove at its maximum speed for half a mile to catch prey, how many seconds would the dive take? Okay. Well, we know that 1 mile is 5,280 feet, right? And we know that the bird dives at a speed at 200 miles per hour. Okay. So we have those two pieces of information, and so we need to see how long it would take for the individual to definitely to dive at that speed. Well, it's in feet, and we're in hours, or we're in miles, and so we don't necessarily want to be in that, and so we want to know how many seconds, again, it may happen to particularly take. So we see here that it's traveling at 293 feet. So we see up top, we've discovered it dives at 293 feet per second, right? And stuff. Well, if it's trying to catch what is at 5,280, so then we should be able to say, let's see here. We can actually kind of flip this around. So half of 5,280 is going to be what? Divided by 2 is going to be 2640, because that's half a mile. So 2640 feet multiplied by 1 second times 293 feet. And so now we're eliminating the feet. So 2640 divided by 293 gives me 9.01 seconds, because that's what's left here, seconds. This is round your answer to the nearest second, so we can then see that the answer choice would then be 9. All right. Well, I certainly hope that you've learned a lot from our explanations that we've given here, and that you can see many of the strategies that we share within class and examples and how they so happen to relate to this test. And as always, if there's a solution that doesn't necessarily make much sense or needs more clarification, please let us know, and we'll clean that up. So thank you so much. Appreciate it, and have a good day.